This program is proudly brought to you by Telecom Limited and Daytech.
In this session of Infocus, we feature the knowledge exchange visit by the Australian Centre for International Agricultural Research Centre and International Centre for Insect Physiology and Ecology about the potential of the black soldier fly larva farming in Papua New Guinea. Joining us for discussions, we have Dr. Chrysanthus Tanga from ICIPE, Kenya, and Dr. Michael Dom from NARI in Lae. Gentlemen, thank you for joining us.
Thank you.
Firstly, Dr. Dom, could you tell us about the main purpose of the visit?
So thank you very much for your time and the question. So this is the second segment of a program sponsored by ACIAR, and this is a reciprocal visit from my colleagues in the research environment, my colleagues from Kenya, from the International Center for Insect Physiology and Ecology. And they've been leading the way in the world, actually, for research into black soldier fly larvae as a feed and fertilizer. And in NARI, where I work in Lae, we've been looking at different sources of feed for animals. So through the connections we'd had with ACIAR, I think we were connected by Dr. Anna Okello, who's the livestock systems manager for ACIAR Australia. And so she brought us together in a webinar meeting. And then the interest commenced from there about how we could use black soldier fly larvae as a livestock feed for poultry, pigs, and fish as well. And so we were taking across to Kenya, myself and colleagues in NARI, to do a knowledge sharing visit to Kenya to see what they were doing there. We'd been doing some work on the BSFL, but to a small degree, and taking us across to Kenya was just a really great learning experience for us. And so to finish that off, ACIAR sponsored the Kenyan team to come here, and we've been visiting in Lae and Port Moresby to see small farms and meet with industry leaders and see what can be done in Papua New Guinea.
Now, Dr. Tanga, insect farming is somewhat of a new concept in many parts of the world. Could you clarify what it entails?
Insect farming from the perspective that we're working on actually focuses on recycling organic waste using insects to produce high-value products that are marketable using insects through a circular economy perspective. This is very critical for us because we are looking at technology that can be easily accepted and adopted by both the youth and women, and that can create job opportunities while meeting the demand of protein and fertilizer within the continent.
Now, could you explain the process of black soldier fly farming in a nutshell for its step-by-step process?
Yeah, black soldier fly is a very important insect. It's different from other insects because it's not a pest. It doesn't transmit diseases, it doesn't bite, it doesn't stink. And so using black soldier fly makes it a farmer's friend. And to grow this insect simply requires the use of organic waste, any organic waste. And the insect is placed on the waste, and within 12 days, the larval stage is ready for harvesting to be used for animal feed, and the residue left is a very good source of fertilizer. And this can be applied in the farms to augment our soil for crop production. So there are so many other products that can be developed within the same value chain, like the oil, the chitin, briquettes, and many others. But I think our key focus, especially with our VTD and Papua New Guinea, is the animal feed and fertilizer because of the demand-driven component of the project.
So how long has it been practiced in your part of the world?
This technology has been practiced for the past 10 years. It was supported by ACIAR as a proof of concept, where we evaluated insects against plant and animal-based sources to be able to establish the feasibility that it could be a better substitute for these conventional protein sources like soya beans and fish meal, which are actually human food products. And so we actually demonstrated that, and right now we are now scaling it across Africa. And so given that this technology has been well optimized and fine-tuned, we think it is time for us to move this beyond the confine of Africa to benefit our brothers across the oceans. So, and that's exactly why we are here with this technology, because it has been fully demonstrated, and we think it's time for us to start scaling the benefits of insect farming to other parts of the world.
Okay. Given this is an innovative form of farming, should there be concerns about patents or copyright concerns?
Yeah, that was a query I had as well when during the visit to Kenya, and I think the approach that ICIPE has taken, and also the farmers and entrepreneurs who've gone on to utilizing black soldier fly as their main business, has demonstrated that there is at the moment no patenting. There are of course some modifications that people have done to materials and equipment, etc., which are there in the private zone of their business. But in terms of using the technology and spreading the skills and knowledge and how to conduct that, there has, up till now, I don't think there's been any challenges to patenting. Dr. Tunga might have some comments on that.
Okay, this is an open technology. As we said, it's a nature-based solution. The insect can grow in any organic waste. Anybody can place the insect in organic waste and still going to recycle the waste. And so there are no issues of patenting, and restriction might only be a level of the equipment that are being developed by private sector partners as a way of improving their productivity. But as far as rearing the insect is concerned, we don't think there are needs for patents at this stage.
Now, Dr. Dom, to what extent does Papua New Guinea possess the necessary environmental conditions for the farming of black soldier flies?
That's a good question. I actually discovered them quite by accident, just growing in silage, in fermented cassava, which I've been working on as a pig feed. And I think from over the last few years, we've been keeping our eyes open, seeing if we can observe the flies and the larvae anywhere else. And I think to most reports, we've seen that it is all over the country actually already. And according to my colleagues now, on arrival, they said this is the perfect environment. So we have correct humidity, really good temperature at which the larvae can grow, and especially the flies can breed successfully. So it's an exciting find. It was an exciting find for us, and we want to see where we can go next with it. We've been, as I said, doing things on a small scale, but from what we've seen so far and shared with our Kenyan colleagues, and especially the entrepreneurs, it is really a doable industry, that from small scale in your backyard all the way up to large scale. Yeah.
Now, Dr. Tanga, drawing from the East African experience, how can regulatory authorities best safeguard consumer health as well as protect environmental standards?
Thank you so much. I think this is one of the entry points that we brought forth when we started this project past 10 years ago. The idea is to bring policymakers on board at the initial stage of the project to also become owners of the project. So as we continue to scale up the project, what they do is to create an enabling environment so that this technology can be taken up, because right now it is new, and so they need to be standards developed to allow the inclusion of insect in animal feed, and also policy environment to allow this technology to be transformed into business opportunities that could actually benefit the youths and women. But the most important part here is that although we have done it for 5 African countries, we are not doing it at the continental level, because I think the demand is very high, and we think a continental standard will allow all the countries to be able to benefit. So given that these guidelines have been well established in Africa, we think Papua New Guinea will also need to follow the guidelines to be able to develop standards based on their own requirements, so that these products are safe and ready for markets without effective quality control parameters in place.
Now, based on the models that were practiced in the East African region, an interesting point to point out is that it was based on good scale and partnerships. Could you comment on that?
Yes, in all our projects, we don't work in isolation. As a research institution, we partner with private sector partners, with private government institutions, and we make sure that all the technology we are developing is actually done alongside the national government authorities, because they are the ones to help in promoting the policy on the use of these insects, and also the uptaking of this technology by the government, the various national government also create an enabling environment for sustainability. And so that is why we think, especially a waste management component as well, we need a lot of law enforcement by the different national authorities to be able to make sure that this waste separation and availability for insect rearing is actually carried out in a more harmonized and consistent manner.
Now, Dr. Dom, what sort of jobs and opportunities will the development of a local BSLF industry provide for Papua New Guinean youths and especially rural citizens?
Surely. We've had one of our colleagues from the Kenyan team, who's a CEO of a large-scale company, crunch some numbers for us, and I'm not gonna try to recall them now, but it is in the hundreds. It is in the hundreds because there's various. You're adding to a value chain actually. So just sourcing the waste in the first place, you need workers to do that. There's the processing, which is, that takes, there's transportation may be involved in that. There's some logistics. There's also the breeding of the larvae itself. It does take some technical skills and knowledge, so you've got opportunities there for young people with a technical or a scientific interest in getting started in there. And then there's the whole business management process of it, which is, that's a separate thing altogether. And we're looking at that as being looking at modeling of small to medium enterprises where young people especially, but not just young people in the community who can take up the challenge of organic waste management. That's an untapped industry, if you like.
Just to add, I think in terms of job opportunities, as Dr. Michael Raleigh said, you have the aspect of waste collection or waste management. You have, in the course of transportation, you need drivers to transport the waste, preparation of the waste, and also processing of the waste for the insects. Then within the insect facility, you have people who are growing the insects, those who are drying the insects, those who are the packaging, those who are also transporting the insects to the market. And you also, at the level of the universities, we are looking at masters and MSc students, PhD students that could be trained within the same project, and this will create opportunity for them to get for new jobs in the professors in the university that could establish research component research opportunities. At the government level, you have agricultural extension officers that could be trained in new areas of research, and they can help in training other farmers. You have other big industry like the pet industry that is actually manufacturing the feed for pets. Feed millers will also create a lot of job opportunities, different levels of the value chain. And you also have the pharmaceutical industry that can also use some of the products like the chitin and chitosan for drug production. And so there's a massive amount of opportunities within the different aspects of the value chain. And also even at the agricultural level.
Absolutely.
Growing the crops, farmers will need to employ young people who can help in soil amendments and harvesting of the crops and marketing of the crops. So we think it's an opportunity that can serve a lot of people in Papua New Guinea and the world at large.
Yeah, that's from the frass fertilizer. So the livestock objective has always been looking at feeds, and of course the larvae are a natural poultry feed, of course. But the waste that remains is called frass after they've processed the organic material, and that is actually a high quality fertilizer, as Dr. Tanga has mentioned, and that has a lot of applications, and there's some really good science behind it. It is also alluded to. And that also needs to be localized, because how does that fit in within our context? So yeah, there's some exciting things, prospects.
It's good you mentioned livestock feed. For the local Papua New Guinea local cattle and poultry industry, access to feed has been a major challenge. What would you attribute such a trend to?
So we've got, of course, increase in population, and that leads to higher food demands. The high quality end now, you want increased protein intake is the number one, so the meat consumption increases. It's a natural trend. And so our farming systems have tried to cope up with that, and poultry production in particular has, I think it's been in the news, they're struggling, we were struggling to produce enough poultry for the country. The same goes for pigs. I think there is definitely a shortage of livestock feed, and most of our feed, I think up to 90% of it, is imported from overseas, and that increases the cost of production for livestock farmers.
It's wheat-based stock feed?
Yes, grain-based stock feeds. So the big ones would be soybean meal. Wheat meal is a basis for all of our livestock feeds. So it's the grain-based feeds that are driving the cost for livestock farmers. And so where we see BSFL coming in is as a protein meal substitute. And to what level is of course NARI's interest on the research side of things. How does that fit into our system? We have things like fish meal, we have copper meal. There's opportunity to get palm kernel expeller. Those protein sources are there, but those are crop-based protein sources, those plant-based protein sources rather. Whereas for the insect meal that we get from the black soldier fly larvae, that is an animal protein. So it's got all the range of amino acids that an animal needs, and as Dr. Tanga will probably explain more on, it's exactly that which makes it much more valuable than say just a soybean and fish meal.
Now, Dr. Dom, I understand you're also undertaking some existing research in Nari and Lake. Could you explain what's been going on so far?
Yeah, so for us, the first feed, livestock rather, that we thought was sort of under catered to in terms of our research. We'd successfully completed also previously ACIAR sponsored research on pigs and poultry feed. Towards the end of that research, we'd included fish into that component, aquaculture fish, specifically tilapia and carp. But we hadn't really satisfied that. We'd come up with pig feeds and poultry feeds, some of the concentrates of which FarmSet Limited, which is a national company, is now producing. But until now, we've not looked at what can we provide for fish specifically. They have a higher requirement, a higher nutrient requirement, especially for protein. So it's a much more costly diet to create. And now that we've seen the black soldier fly and its protein content in there, it can get extremely high. I think the ICIPE people have clocked it in at 50 to, I think it's 60% in excess. That's on really good. So if you're growing them really well, they can get that higher protein content. We've had 30 to 40% here on basically kitchen waste. So that's what encouraged us to look at it as a fish feed first, because the farmers, there's about 20,000 fish farmers at last estimate, don't actually have a feed resource they can go to, a stock feed, whereas you've got poultry feeds, you've got pig feeds, but that was a missing link. So we started with that, and we've created some, as I said, on a smaller scale, but the indications have been really, really positive. And so we're looking at how can we extend that research, and so connecting. That's what drove us to reconnect rather with ACIAR, and see how we can expand that. Yeah.
Dr. Michael Dom, thank you for joining us.
Thank you.
Joining us for this session, we have Mr. Nicholas Ndeke, the owner of Zunga Limited in Kenya, a local agripreneur. Nicholas, thank you for joining us.
Thank you for inviting me here.
Firstly, Nicholas, can you tell us a bit about your company?
So Zunga Limited is actually is a company that deals with food security matters, and our name is derived from Zero Hunger. We are a BSF farm and also a feed mill, and we do feeds for livestock such as pigs and chicken. We are a youth-based company. We were formed in the year 2020 and have been in operation ever since. We recycle at least 40 tons each and every week, 160 tons each and every month.
So far you've been in Papua New Guinea. What has been your impression of the potential of BSLF farming in Papua New Guinea?
As I always started my speeches, that Papua New Guinea and Kenya, we are like, the temperature is awesome. In fact, much more better than there in Kenya, because the humid environment is very thriving for the black soldier fly farming.
Now, Dr. Tanga, a core aspect of black soldier fly farming is the utilization of organic waste. How much quantity of organic waste would be suitable to run a scalable BSLF farm?
Okay, I think this actually depends, because when we talk about scalability, we are looking at benefit everyone. So we think from 100 kg of waste per day, running up to 1,000 to 40,000 tons, as some of the commercial farms are using every day, could actually help in scaling. Because we are looking at scaling from the small holder farmer setting, and we look at the medium scale production setting, and also commercial farms like the Inseti Pro that uses more than 40 tons of waste every day. So I think insect farming is something that can be done by everybody. And I think no matter how small the waste is, you can produce at least some protein or fertilizer could be used at household level or at commercial scale.
Now, Nicholas, from your experience at Zunga Limited, what sort of benefits will black soldier fly farming provide for the average farmer in Papua New Guinea?
First of all, low cost of feed. Affordable, low cost of feed. In Papua New Guinea, I've realized that you import at least $2.5 million worth of feed each and every day. But this is a constraint to the smallholder farmer because they cannot access or afford the feed for their animals. So using black soldier fly, even as a backyard for their backyard, will enable them to grow this livestock at a very short period of time and saving on cost, and as a businessman, more profit.
Dr. Tanga, how will the development of local BSLF industry improve local livestock and aquaculture industries in Papua New Guinea?
Yeah, as Nicholas said, importation of these major protein sources is quite expensive, and we've seen a lot of very few people are involved in livestock production. So if we're able to produce black soldier fly, as we have observed, it spends just 14 days on the waste. That means we can harvest it 26 times in 1 year. That means availability and accessibility will be much more advanced in terms of providing this protein source for the livestock industry. So we think with this protein availability, that can change the livestock production capacity within the country.
Dr. Chrysanthus Tanga and Mr. Nicholas Nandeke, thank you for joining us.
Thank you, Thomas.
Thank you.
Well, viewers, that ends this episode of Infocus. Do join us again next week, Monday, on our regular time slot of 7 p.m. Till then, bye for now.